Once again, supplementary angles. Supplementary angles are two angles that add up to 180 degrees. We know from when we talked about types of angles, there are four types of angles. There's acute, obtuse, straight, right. We just covered complementary. When you put two complementaries together, you get 90 degrees, which is a right angle. When you put two supplementary angles together, they form a straight line. They form a straight angle. Notice here 140 degrees and 40 degrees. If you add those together, you get 180 degrees. That's what it means to be supplementary. Well, what does it look like to be supplementary? Two angles, and I'm kind of getting ahead of myself, but we'll go ahead and talk about this. Two angles that are supplementary, when you put them together, form a straight line. These two angles are known as a linear pair. I'll say that word at least 100 times before the end of the semester, those words. Linear pair, that's extremely important. Again, supplementary is actually the adjective form. Supplement down here is actually the noun form. So the angles 40 and 140 are supplementary. That describes the angles. 40 is the supplement of 140. 140 is the supplement of 40. Okay, that's the noun form. So two angles are supplementary if they form a straight line, if they add up to 180 degrees. So, and that's where I was headed a while ago. Talking about a linear pair. A linear pair is a pair, there's two of them, a pair of adjacent angles. We talked about adjacent the other day. Adjacent means they share a side, they share a vertex. So therefore we see that these are next to each other. Pair of adjacent angles with non-common sides that are opposite rays. I really don't like that definition, but do y'all see how those are opposite rays? They point opposite of each other. I like the fact that pretty much a linear pair are two angles, two adjacent angles that form a straight line. The angles, and you might want to start that, this is a theorem. The angles in a linear pair are supplementary. You already know that. If two angles form a linear pair, then they are supplementary, meaning that the two angles will always add up to 180 degrees. Measure of angle 1 here plus the measure of angle 2 will equal 180 degrees because it does form a straight line. So let's go one more time. We'll go a step further with this whole supplementary thing. Give the supplement of the following angles. And again, supplementary angles always add up to 180 degrees. So 30 degrees. What's the supplement of 30 degrees? You can use your calculator there, type it in for me. 150 degrees. Because if I add 30 and 150 together, I get 180. Add up to 180 degrees. What's the supplement of 123 there, Sidney? Good. 57 degrees because they also add up to 180. And the supplement of 90 degrees, Carson, would be? 90 degrees. The only two angles that are not only supplementary but also congruent. Okay, now let's do some word problems because everybody loves word problems. It says angle W and angle Z are complementary. Stop there. Kirsty, since they're complementary, what do they add up to? Complementary. Say it again. 9. Complementary always adds up to 9. Supplementary always adds up to 180. We good there? Complementary always adds up to 9, and supplementary always adds up to 180. So therefore, you have two angles, W and Z, that are complementary. Now, there's something else special about W and Z. Angle W and angle Z. It says the measure of angle Z is 5 times the measure of angle W. So take that in. Claudia, so which one's bigger? It says the measure of angle Z is 5 times the measure of angle W. Which one's bigger, Claudia? Z. So do this. This is what I always do. I usually let my smaller angle be my X, be my unknown. Okay, I don't know what either one of them is. I'm going to let angle W, which is the smaller one, be X. Well, it says that angle Z is 5 times bigger. You can use a different letter. You can use X's, Y's, Z's. But let's try to keep this as simple as possible. Let's try to just stick with X here. And I want to define angle Z in terms of X. If angle W is some unknown angle, some unknown measure, well, angle Z is 5 times bigger. So if this is 10, then 5 times 10 would be 50. If this is 12, 5 times 12 is 60. If this is 13, 5 times 13 is 65. But it's x. So therefore the measure of angle z would be 5 times x. Let that soak in. It tells us that the measure of angle z is 5 times bigger than the measure of angle w. Well, I don't know w, so I let it be x. But I also know that z is 5 times bigger, so 5x. Now, one method of doing this, which is by far the worst method, is by using trial and error. Anytime you hear those words in math, you just cringe. Trial and error. You don't like trial and error. With trial and error, we know that these two are complementary. So you can plug in some stuff. You can say, well, what if x is 10? That would make z 50. Are those complementary? No. Now, what if x is 12? That would make 5 times 12. That makes z 60 because it's 5 times bigger. What if it was 15? That makes z 75. And you can try that to see, okay, which ones add up to 90, which actually 15 is 75 bigger, right? That's going to be your two answers. The best way. You don't have to use trial and error. Here are my two angles. And the first sentence stated that these two angles are complementary. We have a relationship between the two angles. Not only are the angles x and 5x, but we know that when we add them together, we're going to get 9. Somebody understand the relationship? They're complementary. Z is 5 times bigger, but they're also complementary, meaning that when you add them, you get 90. Solve the equation, you're done. Like terms, x and 5x gives you 6x is 90. Divide by 6, you get x is 15. Now think about what x is. Going back to your original problem, the measure of angle w is no longer x. The measure of angle z is no longer 5x. The measure of angle w is now, in the place of x, 15 degrees. The measure of angle z is no longer 5x, it's 5 times 15, which is 75 degrees. So therefore, there's your two angles. So therefore, the measure of angle w is 15, the measure of angle z is 75. It says the measure of, angle A and B are supplementary. Stop there. Hunter, that word's supplementary. What does that mean? Add it to what? Yep. Complementary versus supplementary. Complementary angles always add up to 90. Supplementary angles always add up to 180. Okay? So therefore, we have one relationship. One relationship between these two angles is they add up to 180. And you also have what the angles actually equal. One angle is 6x minus 1. That's A. The other angle is 5x minus 17. That's B. But since they are supplementary, what can I say about those two angles, Erica? That when I add them, I get 180. There's the equation. We solve the equation. Jackie, help me solve it. Let's put all of our x's together. How many total x's do I have? 6 and 5 gives me 11x. Let's move my minus 1 and minus 17 over to this side by doing plus 1 and plus 17. Or just plus 18. 180 and 18 gives me 198. I think that's right. So 11x is 198. We solve that by dividing by 11. And I think we get 18 for x. But that's not what it asks for. You have to go through finding x, but that's not what it asks for. It says find the measure of angle A and the measure of angle B. And honestly, I want you to get in that habit anyway. If this problem simply said find x, I'd still do this next step, because once you do this next step, you know you're right. If x is 18, the measure of angle A is no longer 6x minus 1. It is now 6 times 18 minus 1, which is 108 minus 1, which is 107 degrees. The measure of angle B is no longer 5 times x minus 17. It is now 5 times 18 minus 17, which is 73 degrees. Now, how confident are we in our answers? These two angles, we want it to be supplementary. Somebody add 107, 73 for me. What do you get? Are they supplementary? We're right. Next problem says, find the value of x and the measure of each angle. Okay, now we're starting to see a little bit. They're not telling us complementary. They're not telling us supplementary. But can you tell me? There's actually two different ways we can work this problem. What's the relationship between 2x and 3x? What would they add up to? Let's see. It would be 5x. And what else will it add up to? 9. So there's your equation, 5x equals 9. That makes sense. Now let's talk about why will it add up to 90. Anytime you have a straight line, that is 180 degrees. Well, do you see the box here? That's half of it. So if this is 90 degrees, then that must mean that this is also 90 degrees. So there's two different ways you could write this equation. The hard way would be this. 2x plus 3x plus 90 equals. You notice that that's all three of the angles. That's 2x, 3x, and 90. What would all three of those angles add up to? 180. But that's the hard way of doing this, right? The easiest way, well, we already know that's half of the 180. Why not just do 2x plus 3x would add up to, like she said, 90. Are those two equations the same? Sure. Take that 90 and move it over there. You're not going to get the same thing. Minus 90, you get that. So 5x is 90, and Destiny, once you solve that, what do you get for x? Good. And we check that. We check that by plugging it in. 2 times x is no longer 2x, but now 2 times 18, which is 36. 3 times x is now 3 times 18, which is 54. And you can check that 36 and 54 does add up to 90. Okay, next problem. Find the value of x and the measure of each angle. Angle ABD and angle CBD. Angle ABD and CBD. What do they have to add up to? 180. Why? It's a straight angle. Does everybody see the straight angle there? 180 degrees is a straight angle, so therefore those two angles, there's your equation. 10x plus 1 plus 9x minus 11 has to add up to 180. But the other word that I want to be looking for, I want us to get used to using these words. ABD and CBD form a what? 2 words? Somebody started to say, I heard it. Linear pair. Anytime 2 angles form a straight line, they form a linear pair. So therefore, there's your equation. Have me solve it, Kyle. How many x's do I have? 10 and 9. 19x. And Kyle, to move the plus 1 over here, what do I do? And how do I move minus 11? Good. Mark them out. I have 19x equals, that's 191 minus 1 is 190. So x must be 10. We always check. If x is 10, we have 10 tens plus 1, which is 101. We have 9 tens minus 11, which is 79. 101 and 79 adds up to 180. There we go. Next thing, next topic of discussion here, vertical angle. Again, another topic. All this whole first chapter is stuff that's essential to the rest of this class. Vertical angles. Anytime you draw 2 straight lines and they intersect, it forms what's called vertical angles. Now you gotta be careful, because anytime you have a straight line, you've also got some linear pairs going on here, right? These 2 angles here, let's call them C, D. Angle A and C there, those form a linear pair. Angle A and B are what's called vertical. Think of it like this. If you had a pair of scissors, okay, as you open, let's say this is your scissors, okay, and you got the blades over here. As you open one side of the scissors, okay, farther and farther apart, there's an opposite side to the exact same thing. And those parts of the scissors do form what's called vertical angles. Now, before we go into what's true about vertical angles, let's talk one more time about what vertical angles are. Well, first off, vertical angles are 2 non-adjacent angles formed by 2 intersecting lines. This is a line. This is not a line. Okay, it's hooked, it's curved, it's whatever. So therefore, anytime you've got 2 intersecting straight lines, 3 and 4 are vertical, 1 and 2 are vertical. 3 and 1 are a linear pair. 1 and 4 are a linear pair. 4 and 2 are a linear pair. 2 and 3 are a linear pair. Know the relationship between what's vertical and what's linear pairs. And don't look at that yet. I'm going to talk about the y here. When you're dealing with vertical angles, okay, 1 and 2. Like I just told you, 1 and 2 are not vertical. 1 and 2 form a linear pair. So somebody tell me something. What's the relationship between angle 1 and angle 2 since they form a linear pair? What else is true about them? Any? You're about to say it. That's right. They're a straight angle, so therefore they are, what's the other S word I'm looking for? Supplementary. Anytime you have a linear pair, they're supplementary. So that means that the measure of angle 1 and the measure of angle 2 add up to 180. Well, guys, what's true about angle 2 and angle 3? They're also supplementary, right? So I want to show you something. Let's do 1, 2, 3. Let's just make up some numbers. Let's say the measure of angle 1 is 30 degrees. How big is angle 2? They got a calculator. Supplementary, right? 150. How big is angle 3? If this is 150, how big is 3? 30. What if angle 1 is 40? That makes the angle 2 140 because they're supplementary. Well, isn't 2 and 3 also supplementary? So it makes angle 3 40. What if angle 1 is 50? 1 and 2 are supplementary, makes angle 2 130, makes angle 3 50. So what's always true about vertical angles? Always congruent. Because you could even go a step further. What if this was 30? Well, this was 150, making this 30. Well, how big is 4? You see the straight line here? So if this is 30, right here, the whole thing has to add up to 180, so would that not make this also 150? Vertical angles are always congruent. Exclamation point. Vertical angles are congruent. Put it in your notes. Again, anytime we put a theorem in our notes, we're going to star it. Vertical angles are always congruent. So that means that this angle is always congruent to this angle. This angle is always congruent to this angle. First problem says the measure of angle 6 is 72 degrees. So here we have 72 degrees. Find the measure of angle 7. Megan, does this have anything to do with vertical angles? Are 6 and 7 vertical? Are they? 6 and 7? No. 6 and 7, y'all see the straight line? 6 and 7 are supplementary. 6 and 7 form a linear pair. So Megan, if 6 is 72 degrees, use the calculator there, and tell me what 7 is going to be. 108 degrees. The measure of angle 8, let's do another one. The measure of angle 8 is 80 degrees. Rachel, are 8 and 6 vertical? Yes. So therefore, if 8 is 80 degrees, how big is 6, Rachel? Careful. 6, 8. Same size. Now, you're right about this would be 100. And how big would this be? 100 as well. Vertical angles, the angles across from each other, always congruent. Another one. Measure of angle 9 is 110 degrees. Brianna, is 8 vertical with 9? Nope. But 9 is 110 degrees, and they're not vertical, but they are supplementary because they form a linear pair. So Brianna, how big is 8? Perfect. And could I go on and find 6 and 7 extremely easy? Yeah. If 8 is 70, 6 is 70. If 9 is 110, and 7 is 110. Next one. Measure of angle 9, Vanessa, is 123. How big is 7?
I can't see it.
I'm sorry. If this one's 123 degrees, here's 9, here's 7. Are those vertical of each other?
Yes, we can see it.
Okay.
They're the same.
They're the same. So if 9's 123 degrees, that means 7's also 123 degrees. They're the same. They're vertical. They didn't ask you to, but if they needed 6, how would we find it? Subtract from 180. Get 7. Get 7. Pretty easy. Let's do some math. Stephen, what's the relationship between these two angles? 78 and 5x minus 2. Finish this equation for me. 5x minus 2 perfect. Those two angles are vertical. You have two straight lines intersecting, just like scissors. As you open this pair of scissors, or this side of the scissors, the other side opens the same amount. So those two are vertical, therefore they must equal each other. We saw this, add 2 divided by 5, you get x is 16. You can plug that in. 80 minus 2 gives you 78. Check. They do equal each other. Any questions? Now the next one's not going to be quite the same. Look at this one. A little bit uglier. You got x's and y's. And if it can be helped, don't mix x's with y's. One example. I know that y minus 12, somebody finish the statement. I know that y minus 12 is equal to what? Okay, good. Aren't those equal? But let's go back to algebra for just a second. As I try to solve this, well, I've got some like terms. I'm going to move my 12 over here. I've got y equals 2x. I add 12. 2x minus 8. Ugh. How do I combine like terms? I've combined every like term that's there. Does anybody know how many answers this has? Infinite. If I plug in x, I get a different y. If I plug in x equals 3, I get y is negative 2. If I plug in x equals 4, I get y is 0. If I plug in x equals 6, I get y equals 4. I get lots and lots of different answers. And if you graph those answers, it would look like a straight line. Y equals 2x plus 8. Remember slope, intercept, and all that stuff. Let's stay away from that right now. We want one answer. Okay, we don't want infinite answers. We don't want to go there. So, to make a long story short, if you don't have to combine y's with x's, don't. I could also use this and this angle. Combine your y's with y's. Let's keep our y's together. Let's keep our x's together. Somebody tell me the relationship between, actually, Caitlin, you do it. Tell me the relationship between y minus 12 and 3y minus 8. They're not equal. I will tell you that. They are not equal. But look where the two angles are. You put this angle together with this angle, put the two angles together, I think it forms a straight line. So what's the relationship between the two? Plus gives you perfect. Those two angles are supplementary. If you put them next to each other, they form a linear pair. They form a straight line. Notice I only have y's. There's no x's here, so I can put my y's together by doing this. Mark it out. Minus 12 and minus 8 move over here. Or you can do plus 20, either way. And I now have 4y equals 200. And Jordan P, if 4y equals 200 divided by 4, what do I get for y? Perfect. Now I can plug that in. If y equals 50, then this angle is 50 minus 12, which is 38 degrees. This angle is 350s, which is 150 minus 8, which is 142 degrees. Now, how confident am I with my answer? Very. Because if I add 142 and 38, I do get that 180 that I was looking for. No question. See if any of this is clear. In order to find what x is, that was y. In order to find out what x is, I could say 6x minus 32 plus 2x minus 20 equals 180. I can do the same thing, but I don't have to. Can anybody tell me another way that I could actually solve for x? A simpler equation, a cleaner equation. Anybody come up with it yet? What's a simpler equation I can use? There's actually two different ones that you can. How about, let's not go there. Let's go 2x minus 20. Perfect. You don't have to do this plus this equals 180. Why not do 2x minus 20? Don't we know that this angle is 38 now? Those are vertical. Why not? Let's just do 2x minus 20 is 38. Will I get the same answer either way? Yes. I'll prove it. Add 20 You have 2x is 58, divided by 2, you get x is 29. 6x's and 2x's gives me 8x's, minus 32 and minus 20. Let's move it to the other side by doing plus 52. That'd be 232. Divide by 8 gives you 29. Same answer either way, except for this way, you didn't have to deal with such big numbers. Another way you could have solved for x. Well, don't you know that these two are also vertical? You could have also said 6x minus 32 equals 142. Add 32, and because of the amazing miracles of math, you get the exact same answer again, no matter how you work it. As long as you work it by following mathematical rules, I know this is true, I know this has to be a fact, you're going to get the same answer no matter how you work it, as long as you follow those basic rules. Here you have lots of angles. And which, by the way, let me share something else with you. We've already know that anytime you have a straight angle, like what I've got marked right there, it adds up to 180. I know that when I have vertical angles, it adds up to, or excuse me, it's equal to the same thing. What about if I go all the way around the circle here? What if I add all four of those angles up? Well, wasn't this 180 and this another 180? What do you get when you add all those angles up? 360. Anytime you go all the way around, okay, same way in basketball, you spin all the way around, dunk, and somebody said 360, right? Or 360. Full rotation. Now, can I use that fact here? Maybe, maybe not. I've got X's and Y's. We've got to be careful. Does anybody see a relationship we can use here? Perfect. 7x is equal to 56. Let me show you why. Mark these straight lines. Ignore everything else. There's a straight line. There's a straight line. This angle, therefore, must be the same thing as this angle because they are vertical angles. Sometimes you might have to erase or trying to blot out another line to where it doesn't confuse you. But 7x is going to equal 56. So x must be 8. That means that now everywhere you have an x, you can put an 8. So not only does this x equal 8, which gives you your 56, but also this x, which makes this a 16-degree angle. 2 times x is 16. Well, don't we have vertical angles here as well? If this is 16, wouldn't this be 16? Now, how in the world are we going to find y? Jordan D., what do you think? How can you find y? So here's your equation. Y plus 56 plus 16 equals 180. And honestly, I wouldn't write that down. You're probably not, when you're solving this, you're probably not going to write it down either. You're going to say, well, these two angles add up to 72. And we know that all three have to add up to 180. So that leaves what for y? 108. Which, and while we're at it, we've got all the other angles. Makes that 108 as well. So you got 56 degrees, 16 degrees, 108 degrees, and then pretty much the exact same angles on the other side because there's lots of vertical angles there.